Hi everyone. Today we'll look at longest increasing path in a matrix. So we are given an m cross n matrix of numbers and we have to find the longest path that has a strictly increasing sequence. In this example, we have this sequence 1, 2, 6, 9, which has a length of 4, and that is what we'll return as the answer. We will use depth first search for our solution. We will have a matrix for the memo. That is, let's say if we start from this cell, if we start from this cell, if we start from this cell, for each of the cells, if that is a starting point, then what is the best length that it can traverse? That is what we will store in this memo. Now let's start with trying out for the first cell. So first cell is 9. So there are two directions it can go, but in both the directions there are no increasing numbers. So it checks out both. There is no increasing numbers. So the best length that it can go to is only itself. So the length that we store here is 1. So we go to the next one. Same story, like it has 3 directions it can go to, but there are no numbers that are higher than 9. So again, the best length it can go to is itself, which is 1. So here we have 4, and it can go in these two directions, and in both directions it has a number that is higher. So it tries out this direction. So we go to 8, but we don't know what is the best for 8 yet. So we do a DFS. The DFS goes into 8, computes the value for 8, right? So from 8, it tries all directions. There is nothing to do. So we have computed and completed it for 8 now. Now 4 has these two options. It can either go take the length of the left or take the length of the bottom. Both are same, so it doesn't matter. But the length for which 4 can travel is 2. We got something better today. So this 2 is recorded here. So these 3 are completed. We'll go to the next one, which is 6. So for 6, there are these 3 directions. It can go upward. There is the only one where the length is higher. Sorry, the value is higher. So it checks it out. So the length is recorded is 2. So the next 6, now this has like these 2 directions, but from there is nowhere to go. So here also the length is going to be 2. So 6 to 9 is 2. That's the length. So this is already computed. This 8 is already computed. So we'll skip that and then go to 2. Right? So for this 2, there is only this one direction which has a higher number, and the value for it is already computed, which is 2. So itself plus this direction will give 2 plus 1 equals 3. So that is what it is going to take. So this has already been computed, and this is the new line that we have computed. So a total is 3. So the next one is 1 here. It can go both in this direction and in this direction. Both are higher. So here it is 2. Here it is 3. So it is going to traverse both and see which one is higher and take it. Right? So here it is higher. So this 3 plus itself, we get 4 here. And finally, we go to this one. So here 8 is a higher number. So we compute, 2 here, and we are done with the program. So the best length, the running best length, we always kept calculating. So that is 4. Whatever is the number that is the highest in this matrix, that is 4. And that is our answer. So let's look at the code now. I think it should be fairly simple at this point. Here's the code. So the rows and columns are the lengths of the matrix. And we initialize a memo with zeros. And then we have this directions just for our convenience. So, we start the program with answer equals 0. And then for each and every cell, we do a DFS and see if it is higher than the answer. If it is so, then we'll update the answer and return it. So let's go to the DFS. In DFS, if the memo of the value that we are doing the DFS for is not 0, it means it is already computed, so we return it. Otherwise, we go set longest equals 1. because even if the cell is not able to do DFS in any of the four directions, or all the numbers in its four directions is lower, still the best it can do is itself, which is the cell itself. So the longest is anyway, the minimum default value is always 1. So we go in all four directions here, and we see if it is within the bounds. If it's within the bounds, and if the neighbor is going to be higher than itself, then we will see if basically this longest, of all the four directions that can enter, whichever is the maximum of it will take. So we'll do the DFS of the neighbor if it meets these conditions. If we have already done the computation, then it will just take it and return from the memo. Otherwise, it will go finish the DFS, and then you take the value. So like at this point, once this loop in all four directions are computed, we would have effectively finished computing the longest for that particular node. So we will record it in the memo and return it. So we do it for each and every cell, considering it as a stat, and whatever is the longest answer will get returned. Hope this was clear. See you on another video. You can do all these simulations. You can try out all these simulations in happme.dev. Please do try it out. Thank you. See you in the next video.